Hi everyone, welcome to Mastery Made Simple channel. Today going to discuss about computational thinking. Computational thinking is a problem solving approach used in computer science to solve the complex problem logically and efficiently. It involves the break down the problem and a design solution that a computer can execute. Decomposition, pattern recognition, abstraction, algorithm design. In the simple term, thinking like a computer to solve the problem step by step. Decomposition means breaking a large complex problem into smaller manageable part. Example: problem: organize a colic event, break into the problem: organizing a colic event, break into venue booking, invitation, budget planning, scheduling. Each smaller task become easier to handle and solve. The decomposition mainly focused on very big project or very big modules. That modules contains a huge amount of code. So each and every code or each and every module split into number of submodules. The submodule can able to solve and integrate it. The decomposition, there are two approaches. One is a top-down approach, another one is a bottom-up approach. So based on the requirement, we can choose the best option. Top down or bottom up approach is better to solve all the problems, to integrate and integrate the single model. It is a easy way of to find the solutions. Benefits: reduce the complexity, makes the debugging easier, enable to teamwork. Abstraction means focusing only on important details and ignoring the unnecessary information. Abstraction, that means of core executions or functional model details, is not a detailed, is a described one. Example: when using the mobile phone, you only care about calling or messaging. You do not need to know internal circuit or so abstraction hides the complexity and shows only what is needed. In computing, variable represent the data, function represent the operations, models represent the real world systems. So real world information, computational data, this means of converting the real world fact into the format that a computer can understand and process. Step 1: collect the real world data. Example: student mark and temperature, attendance. Second one is represent the data in a structure form: number, text, boolean present the true or false. Name is like a text. It's a group of characters used to separate comma. It is used for the group of character separator operators, and marks only the numerical characters or numbers used to comma to separate the marks or separate the numerical values. Storing in computer systems tables in database arrays files. Array is a collection of similar data items, multiple number of values stored in the same variable, but the index value is different. File is a two type majorly used in C or basics, text file, binary file, and CSV file also is there. CSV file is a spreadsheet file, and text file is a notepad or a word is a collection of characters you need to store can able to do. And binary file is like png .jpeg, this type of image file. So process using the algorithm calculate the average and sort the data, analyze the pattern. Example: real world student performance, computational data. Name Ravi, marks 85, grade A grade. This is sample data for computational real world student performance. Computational thinking is a logical problem solving approach. Decomposition is breaking the problem into part. Abstraction, ignoring unnecessary details. Real world to data, converting the real life into a computer readable format. This is an example diagrammatic representation of computational thinking. First one is a problem specification, evaluation, and third one is algorithm. This is another diagrammatic representation of computational thinking. One is a decomposition, algorithm, abstraction, pattern recognition. These are the 4 steps mainly focused for the computational thinking to solve the problems. So computational thinking steps: pattern recognition, algorithm design, abstraction, decomposition. So feature of computational problem, how it will decompose and merge the problems. This diagrammatic representation of abstraction analysis and automation, how it will work in the abstraction. Classification, generalization, pattern recognition, decomposition, simplification, mapping the problem, filtering the information, location, the simulation. This is another complete diagrammatic representation of computational thinking, decomposition and abstraction, how it will communicate and how it will work on it. It's a cluster, n number of clusters and n number of decomposition. Protocols, how it will use in these protocols. Thanks for watching. Subscribe my channel, click over the bell option for further video updates.